Hi viewers, today we are discussing the chapter Work and Energy. So first topic is work. So in simple words we can say that work is a product of force and displacement. So in order to get work we have to just multiply the force and displacement. So this is a pictorial representation. So here is a girl and she is pulling this box from this position to this position. So she is applying a force on this box. Okay, so in effect she is doing a work on this box to move this box from this position to this position. So we can say that she is doing a work and the work is equal to force. She is having a force in this direction and displacement is happening in this direction. So we can say that work is the product of force and displacement. But in this case there comes an angle and all that will be studied in your higher classes. Then units of work. The units of work are Newton meter and joule. So we write the Newton meter as Nm. We write the joule as capital letter J. Then while studying this chapter we have to know that there are many forms of energy around us, and some of the energy forms are mechanical energy, chemical energy, electrical energy, nuclear energy, light energy, sound energy, and there are many types of energies around us. So in this chapter we have to study about some types of energies. So while talking about energy means it is a capacity to do work. Then in this chapter we have to study about mechanical energy, and this mechanical energy is again classified as kinetic energy and potential energy. Then just look at this picture. This boy is riding a bicycle. Okay, then this guy reached the top, then he is again cycling and moving to downwards. So while he is moving from the downhill to uphill, he is moving. Okay, he is moving from this direction to this direction. He is moving. So while moving, we are having kinetic energy. Okay, and this guy stood still here on the top. He parked his bicycle on the top of hill. So this is the baseline. This is the baseline, and from the baseline he is parked in a height. Okay, so anything that is placed in a height will be having a potential energy. And again from this point he is bicycling downhill. Okay, so again he is moving, so he is having kinetic energy. So in short, whatever moves they possess a kinetic energy, and whatever which is placed in a elevation or in a height they will be having a potential energy. So first we are studying about kinetic energy. Kinetic energy, which means nothing but anything which possesses motion, anything which is in motion, they will be having kinetic energy. So here is an archer, and the archer is throwing his arrows. So this arrow will be having what? Kinetic energy. Okay, this moving arrow will be having kinetic energy. So in short we can say that bodies in motion have kinetic energy, and the equation for kinetic energy is half mv square. M is the mass and v is the velocity. Okay, so for kinetic energy we can say running, moving, burst, falling stone, all as kinetic energy. Next we are talking about potential energy. We already discussed the potential energy is possessed due to levels. Energy possessed due to levels, that is what potential energy. And the equation for potential energy is mgh. The m is mass, g is the acceleration due to gravity, and h is the height. So for the examples we can say the water tank, elevated floors, the stretched spring. So this kind of things are having potential energy. So this picture is a transformation. Okay, energy transformation. So here is a girl, she is holding a ball. So this is a baseline or ground. From ground she is elevated in much height. So if she is holding a ball in her hand in a height, that ball will be having potential energy, and if she drop the ball, it started traveling. So what is happening, this potential energy is changing into kinetic energy. So kinetic energy is the energy possessed by the motion, and potential energy is the energy possessed due to levels or height. This is also an example. This while this girl is sitting on the top of this slide, she will be having potential energy. Meanwhile, this boy is sliding out here. So while sliding, he is having kinetic energy just because he is moving. Then comes law of conservation of energy. The law of conservation energy is very simple. We can say it in two lines. The first one is energy can neither be created nor be destroyed. And second one is it can be converted from one form to another form. Okay. Then comes a free fall of stone. So free fall means if anything moves downwards only under the action of gravity. Okay, free fall is the downward motion under the influence of gravity alone. So during this time, during the free fall, potential energy plus kinetic energy will be a constant. Then comes power. Power means rate of doing work. In other words, we can tell that power equal to work by time. Then comes the units. 1 kilowatt means 1000 watt, and watt can be rewritten as joule per second. So 1 kilowatt is 1000 watt. In other words, 1 kilowatt is 1000 joule per second. So while talking about power, the definition is power is defined as rate of doing work. Means how much time a person or a machine needs to complete that work. If a machine or animal or whatever take more time to do a work, it means they have less power. If a machine or man or something like that takes short time to complete that work, it means they have more power. That is the concept of more power and less power. Then comes here comes the power equation. Power equal to work by time, and this comes the substitution equations. We have already written power equal to work by time, work equal to power into time. Okay, then we can write here power equal to work by time. Work is already in the first slide we saw work is defined as force into displacement. So work is changed as force into displacement by time, and displacement by time is the equation for velocity. So power is equal to force into velocity. Then we have to study this one, which means 1 horsepower. 1 horsepower means 146 watt, which means this will be useful for doing some kind of problems in your textbook. Then comes commercial unit of energy. So we might have seen this kind of instruments in our home or in your shop everywhere. So by using this meter, and this meter is known as energy meter. By using this meter, we will be charged for our electricity bill. So while discussing this kind of energy meter, we have to study one unit. That means 1 kilowatt hour means 3.6 into 10 raised to 6 joule. And let's see how it came. 1 kilowatt hour equal to 1 kilowatt means 1000 watt. Then hour is made into second. So 3600 second. Just multiply it with, then it will become 3.6 into 10 raised to 6 joule. So while we getting this kind of LCD bill, it will be written as 45 unit or 100 unit, 200 unit, 500 unit. So 1 unit means 1 kilowatt hour. So if you like the video, hit the subscribe button, click the bell icon and share with your friends.